We actually had some pretty decent luck getting ChatGPT to generate debugging exercises involving strings and arrays, and so I'm pretty hopeful that we can get the same when we ask it for debugging exercises involving structures and maybe even dynamic memory. We probably still have to do a little bit of fighting with it, though, in the meantime to get it to understand what we're asking for. So I want some practice debugging C code that involves structure types. Can you generate a debugging exercise that uses structure types in some way? And, so I'm going to state some restrictions. The code contains several bugs. Let's see, what else do we want to make sure of? I don't want to use dynamic memory just yet. The code does not use dynamic memory. And I'll give it an example of what I mean, malloc or free in any way. I also have to make sure I ask it for, maybe I'm going to change what I'm going to change. Can you generate a debugging exercise in the following format? So I'll do the same thing I did last time, which is I'll say, the exercise starts with a formal specification, which is correct. An incorrect implementation is provided containing several bugs is provided. The code does not use dynamic memory. Don't show me the answer. And then let's see, what else do I want? I'm going to tell it to not use getS. So last time we saw that every time I asked it for code with bugs, it generated me string code that used getS because getS is sort of a free bug. The getS function is not used anywhere. We'll close off that loophole. Okay, let's take a look. So the formal specification is, well, we'll wait for it to finish, whatever. Okay, the formal specification is we're going to be tasked with creating a simple program that manages information about students. So you don't say, okay, so again, it just likes this example. The program will define a structure type named student with the following fields. ID, so student ID, interesting, we're not saying roll number anymore. Name and age, okay. The program needs to provide two functions, initialize student and display student. So it's unclear where the bugs are going to be. I'm going to start by doing a quick skim over it and see what I think. Maybe I can just find the bugs by inspection. So I do a hash define, max name length to be 50. I don't think this should count as a bug because the program may have to make this assumption. Logically, if 50 is too short, we could use 1,000. It seems like it would be a bit of a cheap trick for this to turn out to be a bug. If we had dynamic memory, we could get around this, but we don't. We have initialize student, and I think I see a problem with this. So initialize student doesn't return anything. Instead, it takes a student as the argument and a bunch of details and then fills it in. The problem is that the student it takes as an argument is passed by value. It actually takes the student object and gets its own local variable of type student. And that means that what it modifies in the function the modification doesn't propagate because what it modifies gets destroyed. Speaking of which, I guess I have to have some line numbers here. Can you repeat the source code but add line numbers? I don't know why I have to ask for that explicitly. Okay, so there are the line numbers. I'll wait for it to finish generating. So to me, that means that the error is line 12. I should be taking this as student star. And if the other bug is similar, then I may not even bother writing the fixed code. I think that we can just, we've already seen code at this level. So this should be student star, and I should be using the arrow operator on lines 13 through 15. On lines 18 through 20, I'm displaying the student, so ID, name, and age. That looks fine as long as age is an integer and name is a string, which they are. In main, I've got my two student objects. I call initialize student and I call display student. So I'm only seeing one obvious bug. I'm gonna point out what bug I found. And if it says that there's anything else, then I will go through and actually put it in Jupyter Hub. So I'm noticing a bug in initialize student, where the argument student, which is just, so this is bad naming for arguments for this purpose, but it's this argument. The name of the variable is literally student, should be of type student star, since it gets modified during the function. Do you agree with that assessment? I mean, do you agree that this is actually a bug? You're absolutely correct. And it's now going to generate, it's going to generate a bunch of stuff. So it takes the student argument by value, which means it's working with a copy of the original object. Any modifications made to the copy won't affect the original object, and so on. That's what I said earlier. I changed this to type student star, so I get this signature. It's quite helpfully made the modification to use the arrow operator instead. And so for a midterm question that were just find the bugs, pointing out the bug, that would be sufficient. Now, if it was fix the bugs, I'd want to do this as well. On a midterm, making you rewrite large amounts of code is not in my interest or in yours, but so I probably wouldn't make you write out too much extra code. I might say cross it off on the page or something. And then when calling the function, of course, you don't pass in the value of S1, you pass in a pointer to S1. My question is just, okay, I found that bug, and fixing that bug required a few notational changes elsewhere in the code, but is that it? Are there any other bugs in the code, in the original? Yes. Oh, no. Okay, so it did give away the answer a little bit. So I have to run with this. I forgot to do the thing I always do where I say, don't show me the solution, because it's just so eager to show me the solution. So the first thing is, it says one bug is this, but if you read this, it says it should take a pointer to student, which is what I already talked about. So that's not a bug. That's a bug I already fixed. This thing, the same applies to display student. I don't agree with that. That's not a bug. What it appears to be saying is the display student function could be taking a student star and using the arrow operator. It could, that's true, but it doesn't have to. The way it's currently written also would work. It might not be the most efficient thing in the world, but who cares? The code is valid. It does still work. So I've already covered this. It's claiming that this is also a bug. The string copy function is used to copy strings, but it does not ensure proper bounds checking. Now, that's basically true, but I don't agree with the premise that means the string copy function is somehow dangerous, because all that really means is that if you want to call the string copy function, it is your responsibility to make sure that the array into which you are copying is of the right size. If we go look at the original code, I would argue that it really isn't too much of a danger to use the original string copy here. It is true that when you call initialize student, you need to be aware that whatever name you pass in isn't longer than the maximum length, but arguably I think that's still something reasonable to expect. The caller can do that. However, yes, it's true that there is this alternate function, string ncopy, that only copies up to a certain limit. And so if you write its corrected call, where it copies into student arrow name, and you give it this maximum length, that ensures that the string, there's no buffer overflow. We don't walk off the end of the array in all cases. So that is true. That is one way of being absolutely certain. And in this case, maybe that helps. I don't think it would be that important as long as you're careful to understand when calling initialize student that the string isn't too long, but I definitely push back heavily against any implication that string ncopy is always preferable to string copy. As long as you're aware that it's your responsibility to check the bounds, either function is fine. As long as when you call string copy, you make sure that the destination array is big enough. Okay, so I did that exercise without actually copying and pasting code. Let's ask it for another one. That exercise was nice. Can you generate another exercise? I won't yet ask it for a dynamic memory exercise. I'll keep it on structures. Of course. Okay, so the formal specification. Okay, clearly ChatGPT has a couple of favorite topics when it comes to structure exercises. There's the student database and the book database. You are tasked with creating a program that manages information about books in a library. It'll work with a structure type named book with the following fields. The program has to provide two functions, initialize and display. Now, I really hope for its sake that it's not going to be the same bugs as it was before. Here is the incorrect implementation. Now, because of the way that I did that last one, why don't we actually go through and copy and paste this code in and try and fix the bugs fully like we did before. I'm going to say, can you repeat the code, but add line numbers, just so that when the time comes, I have that information. Certainly, there we go. While it does that, we'll head over here and paste in the code that we copied. Okay, it's generated 2 books. No surprises there. It's unfortunately chosen, well, I already talked about what I think about its choices of books, but fair enough. These are 2 good books, to be fair. Okay, so I've got this structure called book, typedef struct book, and I've got a maximum length for a title and an author. Now, I can see a little bit ahead based on what it complained about last time. I have a feeling that it's going to complain about my use of the string copy function. So as I said in this course, as long as you understand that when you call string copy, it is your responsibility to make sure that the length of the array into which you are copying is sufficient, then I don't see a problem. But okay, let's entertain ChatGPT's I guess expectation, and instead try out this new function called string ncopy. The n there is to indicate that between the destination and source, you provide the limit on the size of the string. So you say copy up to this number of characters, and that's it. And then it seems like ChatGPT wanted to for me to add my own null terminator to be extra sure. So I'll do that. So here I'm saying to string ncopy, copy into this array up to this number of characters and no more, even if the title is longer, do not exceed this limit. That way there's no way, and I don't have to do my own bounds checking, there is no way that we accidentally walk off the end of this array. Now, accordingly, I want to make sure that if string ncopy hits its limit, that I still add a null terminator. ChatGPT seems to think that's a good idea, so I will do it that way. You could also use the original string copy function if before it you put an if statement that checks for the bounds. So that is, it won't do the copy if the string you're copying in is too large. Either way would work, but as I said, why not try this brand new string ncopy function? Max author length -1. And then this is going to be this, and we'll do max author length. Okay, so I think one bug was the use of string copy, because it had that problem before. So that's initialize book. I suppose I should have tried running the program before I did this. So I'll try running it now. What is it complaining about this time? Oh, I think I got the arguments to string ncopy wrong. So it looks like string ncopy actually wants the length as the last argument. So I made a mistake there. Sorry about that. I don't... the order of arguments for string functions and file functions in C is something that I do not have memorized. And I don't think you ought to have that memorized either. You can always bring a piece of paper to the midterm exams and to the final exam for a reason. Okay, so we'll do that. We'll try running that again. Okay, that compiled. So that was just a transposition error. So I think that means that in the original code, besides the small part I already modified, there weren't any syntax errors. So we'll do practice debugging 7. Okay, so it prints out, it calls initialize book, and then it calls display book. And just glancing at this, I'm not noticing any other bugs. So I suspect that ChatGPT might think that I should take book star as the argument here, but as you can see, it works fine without it. Maybe it's less efficient, but it does still work. And there was the issue with string copy. So I'm going to go back over and report my results. In fact, yeah, I'll just report the results. I'll say there are errors. I see bugs on lines 14, 15, just 14 and 15. I don't see any other bugs in the program. Let's see what it says. You're correct. It's now going to, I guess, rewrite it for me. Yeah. So it says there are bugs on lines 14 and 15 related to string copy. As I said, it's making this argument. I appreciate the argument. I agree with the substance of it, but I don't really agree with this argument justifying that we should never use string copy. I think string copy is a valid function. I just think that string ncopy provides us a certain convenience, so we don't have to do our own bounds checking. Okay, and here's its revised version, which pretty much matches what I wrote. And then it says, yeah, there's no other bugs. So to be clear, the program has no other bugs. Yes, this is its way of, okay. This is its way of saying yes, although it then says, however, there could be unexpected scenarios. It's sort of acknowledging that it might not be good at this. I think that's fine. Okay, so there are 2 structure exercises. I honestly, I think if I ask for a third one about structures, it's going to generate another one that's using string copy. And so I don't see the point in that. Similar to how with string exercises, it likes using getS. Let's see if we can get an exercise involving dynamic memory. Can you generate another debugging exercise but this time the exercise should involve dynamic memory. Malloc and free. Hopefully it remembers enough about my specification that it can otherwise succeed. All right, so we're now doing, I think it's generating stuff about employees. Okay, I'm going to ask for line numbers. Okay, can you repeat the code with line numbers? Certainly, there it is. Okay, we'll wait for that to finish. I'm going to start by skimming over it, and then I'm going to see if I notice anything that warrants actually running the code to debug it. I've got a structure called employee. I guess I better read the specification. The specification is you are going to create a program that manages a list of employees in a company. This is pretty much one step removed from a set of students or a set of books, but I appreciate the creativity. Every employee has a name and an age. We don't really need to track the ages of our employees. That's a bit of a legal hazard, but okay. The program needs to provide the following functions. Create employee, which is going to dynamically allocate memory, so I'm expecting to see malloc there. Display employee, so it's going to print it out in this format, and free employee, which frees the memory. All right, that's pretty straightforward. Let's go down to the version with line numbers to take a look. And this is neat because here it hasn't suggested an exercise when we asked it for exercises like this. Here, though, it looks like it is going to be able to store employees with names of any length. Instead of in the previous examples where it just creates a character array of a fixed size, here we can see a char star. And I think that means we're probably going to want to use malloc to create the employee's name. That said, skimming down to create employee, it doesn't seem like that's happening. I am going to copy and paste this code to run it because I want to comment a bit on what's happening there. And then I've got the age. All right, so this create employee function is going to return employee star. And it makes sense to use malloc for that use case because obviously if I'm going to create an employee, maybe I don't want to just send back a copy of somebody. That seems like it would do a lot of extra copies. I'll create them once in a form that won't be destroyed with the scope using malloc, and then I'll return the pointer to what I created. By doing so, of course, I have to make sure I later call free. Display employee looks like it's working fine. I'll come back to this in a second. Display employee looks like it's working fine. Free employee similarly looks like it's working fine, although I will likely have to modify this later. And the main function looks correct. However, I'll bet that when I run this code, it crashes. So the code does have a pretty severe bug, if not more than one. So I'm going to copy this. I'm going to head over here, and I'm going to paste it in. I'll save it, and we'll see if my hypothesis is correct, if the code just crashes when I first try to run it. Okay, it gives a hint. Yeah, the compiler's too good at this. So this is essentially the bug I was alluding to, although it's going to be a string copy issue for ChatGPT as well. I run it and it crashes. Yes. Okay, I think that the entire problem is happening in the create employee function. So here's the issue. What I want to do in this function is make a variable of type employee star. I'm going to move the star over for the sake of this discussion. So I call malloc to create an object of type employee. So I'm going to have this variable called employee, and it's going to be a pointer of type employee star. And the more I say the word employee, the less of a meaning it seems to have to me. And so I call malloc to create me a new structure of that type. So it's going to create it off in the wilderness outside of any scope. So I'll draw that out on my diagram here. This is an object of type employee. Okay, sorry for the bad handwriting. It's hard to write at the top of the screen. And inside that object, there are two members. And this is where we have a problem. So the two members are called name and age. Unlike a lot of structures that we've worked with in this course, name isn't itself a string or an array. Name is just a pointer to some string that has to exist elsewhere. And then there's age, and age is an int. And the issue is, right now, as of the end of line 11, that's what the structure looks like. This pointer here is uninitialized, which means we can interpret it pointing to some sort of random thing in the distance. And actually, I'm going to draw that differently because it could look like a null pointer the way I've drawn it. This is just sort of pointing off into nothingness. We don't know what it's pointing to. And age is uninitialized as well. Line 12, I try and copy in the name of the employee to whatever this points to, but that's nothing. So the program crashes. I think line 12 is where the crash is happening. This warning appears to be the compiler saying the same thing. The compiler is saying, if you try and do this string copy operation, you're going to have a really bad time. So my way of fixing that is what I need to do if I'm going to keep the employee structure the same, so I'm not going to modify the employee structure, is I need to allocate an array. I mean, I need this thing name to point to a real array of characters that I can store a string into, which means I need to use malloc again. So I've created the employee structure. Now I'm going to create employee arrow name is going to be a new character array. So I'm going to call malloc, and I'm going to have to figure out the size of that array, aren't I? So okay, int name length, that equals string length of name. And I then malloc an array big enough to store that length plus 1, name length plus 1 times the size of a char. That's how many elements I want, or how many bytes I want. Again, as I've said in an earlier video, size of char is technically optional, but I like putting it in because it's good to have that habit. You'll notice that in this invocation of malloc up here, I cast the result to employee star. That is a nice habit to build. So in some schools of thought, that is promoted as something you should always do. It is not actually necessary to do that in C. And so while it might be a nice thing to do, I could write char star here to remind myself that what's coming out is a char star. As you've noticed in my examples, I choose not to do that because the conversion from the return value of malloc into whatever you're storing it in can be done implicitly. The reason why people often recommend doing this, so again, just to drive my point home, if we wrote it like this would also be correct, and it would not be a bug. Writing it like this doesn't change anything as far as whether it compiles or not, but maybe it's a good habit. One reason that people are taught to do it this way is because if you use other languages like C++, having explicit casts is more important. But I choose not to do it unless I'm actually writing C++. Okay, so I get the length of the name. I create an array for the name using malloc, so that's happening. That puts my diagram in a state very similar to this. Now I can use string copy. What's neat about this is, in this case, ChatGPT might also say I should use string ncopy. I'm going to argue that no. In this case, this is a completely valid use of string copy. There is no way that I'll need string ncopy because I only use string ncopy to avoid having the destination array be overflowing because there's too many elements being stored into it, because the array I'm copying from is too big. That can't happen here. The destination array will always be big enough because I create the destination array to be big enough. And so I think this string copy is just fine. So I think I've fixed create employee, but I haven't fixed the program because I've now used malloc one more time, which means I have to make sure I go use free correspondingly. So when I free the employee, the first thing I want to do is destroy that array I created for the name. So I call free on employee arrow name. And then I can call free on the whole employee because at that point it's okay to just delete the employee structure. So I'm going to save this and I'm going to try compiling it. We'll see if that compiles. It does, and it runs. So there's my two employees. Their names are Alice and Bob. I can appreciate those names. Those are classic names used for, so you can see A and B there. And there are their ages, although we shouldn't really be keeping track of employees' ages. And we can see they are being printed out. Now, I could do more testing, but for the debugging exercise, I think I have done the debugging. I'm actually going to ask it if it likes my code. I'm wondering if it's going to complain about string copy. Earlier, I pushed back a bit on the argument that we should never use string copy, and fortunately, it served up a case where I would argue this is an absolutely valid, safe use of string copy, and we'll see if ChatGPT agrees with me. Here is my attempt at fixing the code. What do you think? So I'll just paste it right in there, and we'll see what it says. Your attempt to fix the code looks great. It's now going to probably tell me what I did. You've correctly addressed the issue related to dynamic memory allocation and deallocation. By allocating memory for the name field separately and freeing it before the whole employee structure, you've ensured proper memory management. The code should now work as intended without any memory-related bugs. Are there any other bugs that I didn't find? It might give me that weird sort of legalese answer. Yeah, it's interesting how it's suddenly become more humble about that. Based on the code and the fixes, it looks like you've effectively addressed the key issues related to this. As of my knowledge cutoff date of September 2021, and considering provided context, I don't see any other bugs in the code. However, remember that programming is a complex task and sometimes subtle bugs can arise. You know, what's weird about this, as I read through this doesn't just look like ChatGPT being sort of odd, because we know ChatGPT is a bit absent-minded sometimes. This almost feels like this is something they've consciously added to ChatGPT on advice of their lawyers. They might be worried that people will get their own code and plug it in and say, is this code correct? And it's like code to fly a plane or something. And they don't want ChatGPT saying, yes, that code looks good. And then, the autopilot fails. They don't want ChatGPT saying the code is perfect because they don't want ChatGPT to appear to endorse code that might still be incorrect. It's neat because this does, although ChatGPT is certainly not going to be taking the jobs of actual engineers, this is also a problem that engineers have with things. If somebody puts code in front of you, if you become a professional engineer and says, hi, could you look at this 5 million lines of code and tell me if it's correct? You're going to want to be very careful before you officially, as an engineer, say yes. Because obviously, if the code turns out to have a bug that even you could never have found, you might be held responsible. I wouldn't be surprised if the very careful wording it's using, especially invoking the date of its knowledge cutoff, that seems like maybe that one of its fail-safes has kicked in and realized that it shouldn't tell me yes to my question. It should just say, I think so, but it's your problem, not mine. Which is interesting. But certainly, we're doing a much better job of getting debugging exercises. But I've done my 3 exercises for now. We've done some structure debugging, we've done some dynamic memory debugging, and I think, it was pretty satisfying.